Alright, so I think this is recording. We've been looking at solving proportions, and this is where you can actually cross multiply. So here is the key to the worksheet that we're doing. Um, let's see if we can agree and get these answers. So the first ones are pretty straightforward, I believe. You have x over 6 is equal to 3 over 8. The technique that we're going to use, I suggest that you draw real light guidelines through there just to make sure that you don't make any type of silly mistake. You multiply along the diagonals. 8 times x is 8x. 6 times 3 is 18. Divide both sides by 8. Write 18 and 8 as products. They're both divisible by 2. 18 is 2 times 9. 8 is 2 times 4. Common factors cancel because 2 divided by 2 is 1. So you can leave your answer as an improper fraction. So I'm getting 9 over 4 for the first one, and 9 over 4, well, not for the first one, for number 6. All right. So if we move on, again, if we cross multiply along that yellow highlight, multiply along this line, we've got 14 times x and 7 times 3. Undo this multiplication by division to get the x by itself. Reduce this fraction. Recognize that 21 can be written as 7 times 3. 14 can be written as 7 times 2. 7 divided by 7 is 1. And we get 3 halves. Alright. Again, we have an equation that they refer to as a proportion. One technique to solve proportions is to cross multiply. You cross over the equality sign. 6 times x is 6x. 4 times 5 is 20. You have on the left hand side you have two factors. You want the factor of x by itself. To undo this multiplication, you do division. You divide both sides of the equation to balance the equation. Recognize that both 20 and 6 are divisible by 2. 20 can be thought of as 2 times 10. 6 can be thought of as 2 times 3. 2 divided by 2 is 1. So we have a final answer of 10 over 3. Alright, so here, now that it's getting a little more difficult just because of the complexity, but the technique remains the same. You have a fraction equal to a fraction. That's referred to generally as a proportion. We're going to multiply along the diagonals to get their products, or sometimes they'll refer to it as cross products, and set them equal to each other. We have 7 times this binomial. We need to have parentheses around the binomial because each term inside the parentheses is going to be multiplied by 7. And the same 5 times this quantity, 5 times this binomial, x plus 3. So multiplication distributes over addition. We have two terms here. Both of these terms get multiplied by 7. 7 times the first term, and then multiplication distributes over the addition, and 7 times 2 is 14. Same thing with the 5. We distribute it. Each term in the parentheses gets multiplied by 5. 5 times x. Multiplication distributes over the addition, and 5 times 3 is 15. Let's get the x's on the left-hand side and the constants on the right-hand side. Let's subtract 5x from both sides of the equation. That results in 2x plus 14. These terms cancel each other. is equal to 15. We need to get the x by itself. Let's subtract 14 from each side. The 14 minus 14 cancels. We have that 2x is equal to 1. To solve for the x, we need to get rid of the 2. Since it's multiplication, the inverse operation of multiplication is division. We divide both sides by 2. 2 divided by 2 is 1. And we get x is equal to 1/2. Here again we have a proportion. Our technique is going to remain the same for all of these. Multiply along this diagonal, multiply along this diagonal, and set those products equal to each other. 6 times 2x, 3 times the quantity x plus 2. On the left hand side we have 12x. On the right hand side, multiplication distributes over addition. We've got 3 times the first term plus 3 times the second term. Let's subtract 3x from each side to get the variables on the left hand side of the equation and the numbers on the right hand side. 12x's take away 3x's leaves us with 9x's. The 3x minus 3x cancels. Divide each side by 9. 9 divided by 9 is 1. Recognize that 6 and 9 share a common factor of 3. We can think of 6 as 3 times 2, and 9 we can think of it as 3 times 3. These common factors cancel. 3 divided by 3 is 1, and we get 2/3. So it's kind of beginning to be a little bit repeat. We have a proportion, the claim that a fraction equals a fraction. The technique that we're using is to cross multiplication, to take the cross products and set them equal to each other. 5 times this binomial, we need to have parentheses around it. 3 times this binomial, and again we need parentheses. Multiplication distributes over addition or subtraction. Inside this binomial we multiply each term by 5. And here in this binomial each term gets multiplied by 3. Let's collect the variables on the left hand side and the constants on the right hand side. The opposite of 3x is negative 3x. (3x minus 3x cancels). Let's add 20 to each side to get the variable by itself. Divide each side by 2. To undo this multiplication, we do division. We can leave our answer as an improper fraction. 29 and 2 are both primes, so that's our answer. Excuse me. If we multiply, we have the proportion, so we'll take the cross product. And if we multiply along this yellow diagonal, 3 times this binomial, 3x minus 2. 5 times this binomial, 5 times x plus 2. Multiplication distributes over addition or subtraction. 3 times this first term is 9x. 3 times this second term. And again, multiplication distributes over the addition. Let's collect the variables on the left-hand side. (5x minus 5x cancels). Let's add 6 to each side. The negative 6 and positive 6 cancel. Divide both sides of the equation by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. For the first time now, we have a variable in the denominator. We had constants in the denominators in the previous problems. We didn't see a variable in the denominator. So, I can right now recognize that the solution to this equation cannot be 5 because we can never have a 0 in the denominator. Take any number that you want, like say 6, and if you try to divide it by 0 on a calculator, it'll give you some type of an error message because division by 0 is undefined. On the right hand side, by the same argument, x cannot be 4. If we get one of these two answers, we'll have to throw them out, and they refer to those as extraneous, extra solutions. So we need to multiply along the diagonals, just as before. This time we need parentheses around each binomial. We've got x minus 4 times x plus 6 and x minus 5 times x plus 2. So I would suggest that you multiply these in the form of a table. X squared, 6x, negative 4x, and negative 24 is the body of our table. We see along one diagonal that there are common terms. 6x's take away 4x's is 2x's minus 24. And if you did the same thing over here, you'll get x squared minus 3x minus 10. If we subtract x squared from each side of the equation, the x squareds cancel. The resulting equation is now linear. It has the exponents on x are 1. It makes the problem easier to solve if you do not have quadratics. Alright, so let's get the x's on the left hand side and the numbers on the right hand side. Let's add 3x to each side. The resulting equation, 2x's plus 3 more x's, is 5x. The negative 3x and positive 3x cancel. To get the numbers on the right hand side, let's add 24. The negative 24 and positive 24 cancel. 24 minus 10 is 14. To get the x by itself, we divide both sides of this equation by 5. And we get that x is equal to 14 over 5. And notice that 5 and 4 was not our answers down here, so we don't have any extraneous solutions. Again, we have a proportion, the claim that two ratios are equal to each other, that two fractions are equal to each other. Our chosen technique to solve these is to take the cross product and set them equal to each other. Along the yellow diagonal, I'm multiplying those two binomials. Along the purple diagonal, I've got 2x minus 3, 6x minus 5. So I suggest that you multiply these in the body of a table. On the left hand side, I get 12x squared plus 17x plus 6. If I were to do the same thing on the right hand side, I would have 12x squared minus 10x minus another 18 minus 28x plus 15. If I subtract 12x squared from each side, the x squareds cancel. Twelve x squared minus 12x squared is 0. And the same on this side. Let's go ahead and add 28x to each side to get the x's on the left and subtract 6 from both sides to get the constants on the right. So if we add 28x here, those will cancel. And if we add 28x here, what do we get? So if I've added these together right, we get 45x plus 6. These terms cancel. If we subtract 6 from each side, then we'll have the term that has our x by itself. And we have 45x is equal to 9. If we divide both sides by 45, let's continue up here. The 45 divided by 45 is 1. Let's write 9 as 9 times 1. And 45 is 9 times 5. 9 divided by 9 is 1. And we have a final solution of 1/5. Now, I should have commented over here with variables in the denominator. Excuse me. We have to state our restrictions. This 2x minus 3, if we were to get 3/2, we would have thrown that answer out, because if we multiply 2 times 3/2 is 3, and 3 minus 3 is 0. Over here, if what I'm doing is taking the denominator 3x plus 2, setting it equal to 0 and solving that. So that would result in 2 steps. You subtract 2 and then divide by 3. Neither one of these excuse me, possible extraneous solutions were our actual solution, so we end up having nothing to worry about. So here it's a little bit easier to see what we need to avoid. 2 minus 2 would give us a 0 in the denominator. We can't have a solution of 2. Negative 1 plus a positive 1 would also give us a 0 in the denominator. To solve the proportion, we take the cross product. So we've got this x plus 1 times x plus 3 along the yellow diagonal. And x minus 2 times x plus 7 along the other diagonal. So I suggest that you multiply these in the form of a table, unless you can look at it and through experience get x squared plus 4x plus 3, and on the right hand side x squared plus 5x minus 14. If you subtract x squared from each side, the x squareds cancel. The resulting equation, 4x plus 3 is equal to 5x minus 14. If I collect the variables on the left-hand side and the constants on the right-hand side, I'll subtract 5x from each side. 4x's take away 5x's is a negative 1x. These terms cancel. If we subtract 3 from each side, we've got 3 minus 3, which cancels, that's 0. Negative 14 minus 3 is a negative 17. If we multiply each side of the equation by a negative 1, that changes the sign of both terms, and we get that x is equal to 17. 17 is not 2, 17 is not negative 1, so we're fine. We don't have any extraneous solutions. That's our only solution to this proportion. We look at the denominators and we see that x, we can't allow x to be positive 2. We can't allow x to be a negative 2. The technique of when you cross multiply might introduce extraneous solutions, solutions that don't satisfy the original equation. Along the yellow diagonal, I have x plus 2 times 2x plus 1. Along the purple diagonal, I have x minus 2 times 2x plus 1. This time, before I multiply in the form of a table, I notice that I have the same factor on each side of the equation. It'll save time and effort if we divide both sides of this equation by 2x plus 1. These factors cancel. We're left with x plus 2 is equal to x minus 2. If we subtract x from both sides of these equations, the x's cancel. We get an equation that's nonsense, so there's no solution to this original proportion. That answer was number 16. It's been a while since I checked our answers. At the beginning of the video on the first slide, I posted the answer key. So let's check number 16. They have something different from number 16. So let's go back and check my work. I'm going to simply do the problem over again and then compare. So I started out by multiplying, taking the cross product. I've got along the yellow diagonal x plus 2 times 2x plus 1. Along the purple diagonal, x minus 2 times 2x plus 1. And I'm confident that the 2x plus 1's cancel each other out. If I divide this side by 2x plus 1 and divide this side by 2x plus 1, so I'm still getting a no solution. So I disagree with the answer key. I claim no solution. Now, what their claim is that x is equal to negative 1/2. Let's plug that into both sides of the equation to see if it's true. So on the left-hand side, if we replace x with negative 1/2, let's use a calculator to determine what number this is. In the numerator, I have 2 times a negative 1/2 plus 1. In the denominator, I have a negative 1/2 minus 2. My calculator is saying that that's equal to 0. On the right hand side, I'm getting probably another 0. So their solution is correct and mine is wrong.